What if a virus followed the same rules as the universe itself? Not just biology, but the laws of space, time, and energy. It sounds impossible. Because viruses are simple, tiny, primitive. But what if they aren't as simple as we think? For over a century, science has been divided into two worlds. Physics, the study of the universe. Biology, the study of life. One explains galaxies. The other explains cells. And rarely do they overlap in unexpected ways. But sometimes, nature does something strange. Something that forces us to ask, are the same rules guiding everything? To understand this mystery, we need to go back to one man, Einstein. He showed us that the universe is not fixed. Space can bend. Time can stretch. Energy and matter are connected. One simple equation changed everything. E equals mc squared. It tells us that matter is just another form of energy. Now imagine something completely different. A virus. So small, it can't even be seen without powerful microscopes. It doesn't think. It doesn't move on its own. It exists only to replicate. At least, that's what we believed. Scientists began noticing something unusual. Certain viruses behave in ways that seem almost optimized. Not random, not chaotic, but efficient. As if they are following deeper rules. Rules that resemble something. From physics. Every action in nature costs energy. Cells use energy. Machines use energy. Even viruses must obey energy constraints. And here's where things get interesting. Some viral processes appear to minimize energy usage, almost perfectly, like a system designed to follow the most efficient path possible. In physics, there is a principle. Systems tend to follow the path of least resistance, the path that requires the least energy. Light takes the fastest route. Particles follow optimal trajectories. And now, viruses seem to do something similar. At first, scientists thought this was coincidence. But as research continued, patterns emerged. Replication efficiency, structural design, survival strategies, all pointing towards something deeper. If viruses follow the same efficiency principles as physical systems, does that mean life itself is governed by physics at a deeper level? Or are we seeing something we don't fully understand yet? What if viruses aren't just biological, but physical systems operating at the edge of energy and order? And if that's true, what else in life follows these hidden rules? In Part 2, we go deeper. We explore how viruses might follow information theory, the connection between entropy and life, and the shocking possibility that life itself is shaped by the same rules as the universe. Subscribe to Science in Silence, because the truth is just beginning. What if life isn't random? What if even the smallest things, like a virus, are following the same rules that shape the universe itself? In Part 1, we saw something strange. A virus behaving not just like biology, but like physics. And now, we go deeper. For a long time, we believed life followed its own rules, separate from the cold, mathematical laws of physics. But modern science is revealing something unexpected. Life doesn't escape physics. It obeys it. Every cell, every molecule, every virus is part of a physical system. And, like all systems, it must follow certain laws. There is one rule that governs everything: entropy, the tendency of systems to move toward disorder. Left alone, things fall apart. Structures break down. Energy spreads out. This is the direction of the universe itself, from order to chaos. But here's the mystery. Viruses create order. They take over cells and build precise copies of themselves. Structure, function, efficiency, all emerging in a universe that prefers disorder. So how is that possible? The answer lies in energy. Life doesn't break the laws of physics. It uses them to create order. A system must consume energy. Cells do this constantly. And viruses? They hijack that process. They don't create energy. They redirect it, optimizing it for one purpose: replication. But there's something even deeper, something beyond energy: information. A virus is not just matter. It's a set of instructions, encoded in genetic material, like a program, like code. And just like in physics, information follows rules. It can be compressed, copied, transmitted. Think of a virus like a message that says, "Make more of me." And it delivers that message with incredible efficiency, minimal structure, maximum output, almost like it's optimized by the laws of nature itself. Now the picture becomes clearer. Physics describes energy and matter. Information theory describes data and structure. And biology is where they meet. A virus sits exactly at that intersection. Not fully alive, not fully inert. A bridge between worlds. If viruses follow these universal principles, then maybe life itself is not accidental. Maybe it is the natural result of energy flowing, information organizing, systems optimizing. In other words, life could be what the universe does. We thought viruses were simple. We thought life was separate. But now, the lines are blurring between physics and biology, between matter and information. The same rules that guide stars may also guide life. And if that's true, then the universe isn't just a place where life exists. It may be a system designed to create it. If this changed how you see life, subscribe to Science in Silence, because the deepest truths are still hidden.